Hi, Algebra 1. This is the review of this worksheet that we're working on, if I can find it. Where's that? It's not there. Okay, so if we take a look at this, let's see if that's going to work. That'll work, right? Got it. Cool. All right, a dance marathon. 256 couples join the dance floor to begin the dance competition. Each hour, 75% of them are limited from the dance floor. So I'm going to realize that it's 100% minus 75%. So that's going to give me 25% are left on the dance floor after each hour. Okay, 25% is 0.25. So we're multiplying. So this is going to be discrete because we're talking about people. I'm not going to have a portion of a person. Is this relationship between time and the number of couples remaining on the dance floor linear or exponential? I would say it's going to be exponential because I'm multiplying each hour by 0.25. What is the domain of the function? I'd say the domain would be, you're starting with, a certain hourly amount and you're going to an infinite amount. Okay, check to see how your teacher wants you to write the domain, but that's one way of writing it. We could probably also get away with saying that it is rational numbers, but we're not going to worry about that too much right now. Write both the explicit and recursive. So the recursive is going to be like next times 0.25 or something like that. And then our explicit is going to be f of n is equal to, we have our 256 out there, raised to the n, 0.25 raised to the n. And that would make that equation work very nicely. All right, so let's come down here. Let's complete the table. So we start out with 256. And if we're going down 0.25 each time, so if I get 256 times 0.25, so after the first hour, it's down to 64 people. Multiply that by 0.25. At the second hour, down to 16. Third hour, we're at 4, etc. So what's basically taking place is that 256 is here, and then each hour it's coming down by half. So that's basically what it looks like. I didn't scale it right, but I mean, you could have scaled it as 1, 2, 3, or 0, 1, 2, 3, 4, 5, and then you could have scaled this way as, oh, I don't know, maybe 20s, 20, 40, 60, 80. See if that would have gotten you up there. All right, the next one says customers purchase concert tickets for $75 each. What is the relationship between the number of tickets purchased and the cost? Is it discrete or continuous? Well, it's discrete because one ticket is equal to $75. Okay, so you're not buying a portion of a ticket. Is this relationship between the number of tickets purchased, the cost linear or exponential? It's going to be linear. Okay, how do we know? So $75 for every one more ticket I buy. What is the domain? So our domain, we could have said that it would have went from, we could have bought no tickets up to however many for the venue. We could say infinity. It's kind of goofy. Notice I have a square bracket here. The recursive is going to be next plus 75. And our explicit is going to be f at n or f at t or whatever we label it to be 75n plus 0 because you could start it at 0. So if I bought no tickets, if I bought one ticket, I bought two tickets, so on and so forth. So if I did my XY axis. Negative 0, maybe count out this to be 1, count out this to be 2, count out this to be 3. And then let's count by 25s. So 25. So at 0, 0, at 1, 75. It's like the third line up. At 2, it'd be at 150. And it just kind of keeps growing that way. Okay, keep it dotted because it's discrete. While driving down the road, you travel at 50 miles per hour, and you drove for 7 hours. Okay, this would be continuous because we don't just get to 1 mile. We did all of the fractional amounts between there. Okay, is it linear or exponential? It's linear. So each hour we drive, we put an additional 50 miles on. And then what is the domain? So the domain we could do a couple ways. If we didn't do any driving, or if we went up to 7 hours, that could be our domain. Square brackets because I didn't have to go anywhere. Right, both the explicit and the recursive. So the recursive would be something like next plus 50, and our explicit could be f at n is equal to 50n plus 0 because we didn't drive anywhere. If we complete the table, so if we didn't go anywhere, we did 1 hour, 2 hours, 3 hours, 4 hours, and we can keep going on that. So I've had 0, and let's count out like 5. There's 1, 5, 2, 1 to 5, 3, 4. So at 0, 0, and then maybe I count these as 25s. So there's 1 there, 1 there, 1 there, 1 there. And we're going to connect these because it is, we said that it was linear, and we said it was continuous, so we're driving the whole thing. Okay, remember on your sheet, your bank account's starting at 100, okay? It says your account earns 3%, so I'm going to go 100% plus 3%, and that's going to give me 103%, which is going to be 1.03. All right, is this discrete or continuous? It's continuous. It says throughout the duration of the month, so it's going to keep growing. Is the relationship linear or exponential? It's exponential because I'm going to multiply each time by 1.03. What is the domain? Well, it looks like I started at 100, and it's going to go up to infinity. Okay, is it really going to go to infinity? No, but theoretically, that's mathematically where it takes place. Write the explicit, so, and a recursive. So a recursive is going to be next times 1.03. And the explicit is going to be f at n is equal to, we started out with 100, we're growing at 1.03, and we're raising that to n. So at 0, we started with 100. And then after a month in there, after 2 months in there, after 3 months in there, so on and so forth. So here's your months down here. I can make a better line than that. So first month, second month, third month, fourth month. So we start at 100. And so this month it's up just a little tiny bit, up just a little tiny bit, up just a little tiny bit, up a little tiny bit. So this is going to be continuous because the money grows throughout the month. And then we come to solve these equations. So I'm going to add 10 to both sides here. That's going to give me 7x is equal to 21. Divide each side by 7. So x is equal to 3. Second problem, I'm going to add 4 to both sides. So we get negative 6x equals 16. Divide each side by negative 6. So we could get probably negative 8 over 3. If you gave me a decimal, if you gave me the answer negative 2.7 or something like that, you're going to be fine. This one I'm going to distribute over the parentheses first. So that gives me 3x minus 12 equals 18. And then we're going to start adding back and forth. Divide each side by 3. So x equals 10. For this problem, perhaps we should multiply everything by 7 first. So that cancels those out. So I get x plus 14 equals 70. Subtract 14 from both sides. So x is going to be equal to 56. For this one, I'm going to multiply everything by 12 because I have 2 denominators. One of the denominators is 3 and one's 4. So if I multiply that or reduce that, so I'm going to get 3x minus 36 equals 3 goes to another 4, so 4x plus 12, and then go ahead and solve it. So let's subtract 3x from both sides. Those cancel. X plus 12, subtract 12 from both sides. So I'm going to get x equals negative 48. Number 26, I'm going to go ahead and distribute 2 over the parentheses, so that's negative 6x plus 10 equals negative 16. I'm going to subtract 10 from both sides. So negative 6x is equal to negative 26. Divide each side by negative 6. Negative over negative is positive. And if you want to make it a decimal, that's fine. So 26 divided by 6 is positive 4.3, repeating. On this one, let's combine these like terms first. So I get 3x plus 5. 8x minus 2x is 6x minus 9. And then subtract 3x from both sides. Those cancel. Add 9 to both sides. So that's 14 equals 3x. Divide both sides by 3. So if you wanted to make it a decimal, you just go 14 divided by 3 on your calculator. So 4.6 repeating. For this problem, subtract 2x from both sides. So that's going to give me 7x plus 10 equals negative 4. Subtract 10 from both sides. So 7x equals negative 14. Divide both sides by 7. So x equals negative 2. For this one, I could probably distribute the half. So that's going to give me 3x minus 9 equals 4. Notice I didn't have to multiply the half over to the 4. And then I'm going to go ahead and add 9 to both sides. So 3x is equal to 13. Divide each side by 3. And then if you want to do on your calculator, go 13 divided by 3. You could leave it as 13 over 3, but it comes out to 4.3 repeating forever. And then number 30, let's see, I'm going to combine these like terms. So I get negative 5x minus 6 equals 5x plus 4. Let's go ahead and add 5x to both sides. Those cancel, so I get negative 6 equals 10x plus 4. Subtract 4 from both sides. So I get negative 10 equals 10x. Divide both sides by 10. So 10 over 10 is 1. Negative 10 over 10 is negative 1. Next problem, let's go ahead and add 9 to both sides. Those cancel. That's negative 3. Divide each side by 3. X equals negative 1. 32, let's multiply everything by 3 to get rid of that fraction. So I'm going to get x minus 9 equals 21. Go ahead and add 9 to both sides. Those cancel, so x is equal to 30. Okay, so hopefully that'll help you with your quiz that you will have on Tuesday. Have a nice day, everybody.